do chapter 3, if I can find my screen. This one. Okay. Okay. We're going to prove identities. Today is actually kind of similar to what we were doing in lesson 2. Okay. The difference is every single question today is going to be an equation. So you have stuff on the left and you have stuff on the right. And you just need the two sides of the equation to eventually be the same. You are allowed to manipulate the left side of the equation. You are allowed to manipulate the right side of the equation, but you just need them to become the same. There are 3 tips, okay? Tip number 1, rewrite them as sine and cos. So if you see any tans or cotans or secants or etc., you're going to rewrite it as sine and cos because that's what our identities are in, right? Then leave the simpler side alone as much as possible. So for example, if we scroll down to side number 2, we'll see there's a complicated side and an easier side. You're going to work more on the complicated side and kind of leave the easy side be for as much as possible. And then number 3, factoring is going to come in today. So factoring can help quite a bit. We're going to factor difference of squares and trinomials. Okay. Yeah. So here we go. I have 1 minus cos squared x equals sine cos tan. Now, like I said, if you see something that's not in terms of sine and cos, rewrite it in terms of sine and cos. So the only thing I got here that I got to figure out or rewrite is the tan. So I have 1 minus cos squared x equals sine x times cos x. And then instead of tan, I will rewrite that as sine over cos. And the reason we want to do that, because now on the right side, I can cross stuff off. So on the right-hand side, we are going to cross off a cos and a cos. So now let's just rewrite what I have. I have 1 minus cos squared x on the left, and on the right, I have sine squared x because I am just multiplying those two sines together that are left over. And I am very close to being done. Who can tell me why? Neil? That is literally a trig identity right there, okay? 1 minus cos squared x and sine squared x are the same thing. But what I also want you to get in the habit of is always swapping one out with the other one so that your left and your right side look identical. So I'm going to swap out 1 minus cos squared x with what it equals. So it equals sine squared x. So my left side is sine squared x. My right side is sine squared x. And now you can stop because the left and the right are the same. The other option, of course, you could have chosen to swap this out for 1 minus cos squared x, right? It doesn't matter. They're interchangeable. So that's one option. The other option, you might have seen this as an answer instead. I left the left side alone, but then I swapped out the right side instead. Both of those prove it. Done. On to the next one. Okay. So in my tips, I said tip number 1, change anything to sine and cos where possible. And then tip number 2 was to leave the easier side alone. So my first step is going to just switch this to sine and cos, or cos over sine, right? And then leave it alone because it's the easier side. So I'm going to recopy my left. I'm not going to work on him yet. And on my right-hand side, cotan is cos of x over sine x. Now, I'm going to leave my right side alone now. He's pretty simplified. He's pretty easy. And I'm going to start working on the left side. Now, we see the sine 2x on the bottom, and we're happy. We know we only got one option for that, right? But up top here, cos 2x, that's where we have the 3 options. But you can actually look ahead and eliminate some of these options. And this is how you do that. If I want my left side to look like my right side, I need to have just a sine x on the bottom, right? Okay. So let's write my denominator out. Okay, so my right side stays as it is. And on my left side, I'm actually going to do the denominator first because my denominator only has one option. I'm like, that's literally all I can do. So I know my denominator will become that. And now that I see that, it might help me pick which coast one is correct, knowing that in my denominator, I want everything to cancel except the sign, right? Like the only thing I want left in my denominator is that guy. So it looks like my right-hand side. Are you following me so far? So that means whatever I decide to put up here has to have a 2 on it so I can cancel the 2's off, and has to have a cos on it so I can cancel the coses off. So which option has a 2 in it and a cos in it? And also, we can't forget my numerator also had a positive 1. So I want that to cancel too. So with all of that in mind, there is one and only one option that will do all of that, and it's this guy right here. It was my side that did it. It heard me. It was like, no, I'm not messing with her today. Okay, so now on top, I have that 1 plus, right? And then cos of 2x, I'm choosing this guy. 2 cos squared x minus 1. So now, if I cross off everything I said I could cross off, the 1 minus 1 cancels to 0. I just have a 2 up top now, 2 cos squared x. So the 2's also cancel each other out because they're divided. And then now I can cross off my top cos with my bottom cos, but just remember, you still have 1 cos left up top. So I'm kind of doing a lot in one. So my apologies if that got a little bit messy. But essentially, after we cross everything up top, the 1's are gone, the 2 is gone, and I only have 1 cos left. And on the bottom, I crossed everything off except for the sine x. And look at that, my left side is my right side. We are happy, all done. Any questions so far? Okay. Number 3. All right. So rule of thumb, whenever you have fractions added together, usually you're going to have to find common denominators. That's just the reality of adding fractions, right? So if you look at your denominators there, we want to have common denominators. They are different right now. Yes? So what's the common denominator? What am I going to do to make those two fractions actually over the same thing? No, we're not going to flip them. Well, that's not what, sorry? Yes. So if I just multiply 1 plus sine x to that guy, it has both now. And then if I multiply this guy by 1 minus sine x, it has both now. So they both have those two brackets. But once you do it to the top, or sorry, bottom, you have to also do it to the top. So I am multiplying the top and bottom by the same thing. Whoever said flip them, that's interesting. I'm going to try that after, okay? Because I didn't have that in my notes. All right. Now, up top there, I actually have to distribute that cos into that bracket. So cos x times 1 is just cos x. And then cos x times sine x is just cos x sine x. Then that is added to the next fraction, and I repeat the process. I distribute cos into that bracket. Cos x times 1, cos x. And then cos x times negative sine x will be a negative result, and then it's cos x sine x again. So getting that negative right is really important because that allows us now to cross off, or sorry, cancel out a couple of terms up top. Now, all of that is over now my common denominator. And my common denominator is actually the result of a difference of squares. I'm going to write that on the side. My common denominator is 1 minus sine x multiplied to 1 plus sine x. Right? I got both brackets. That is a difference of squares, like the result of a difference of squares, right? I have two identical terms with a minus in one set, a plus in the other set. So that means to multiply those out, all I really have to do is do a difference of squares backwards. So if my first term was 1, I square it to go back, which is still just 1. And if my second term is sine x, I just square it to go backwards. So sine squared x, and a difference of squares always has a minus in the middle. So I essentially just FOILed those out and ignored the middle terms because I know they cancel out anyway. So my denominator is 1 minus sine squared x. And don't forget, all of this equals your right-hand side, which we're not touching because there's nothing to do to him. Right? He's simple. Leave him alone. Okay, now let's clean up because on the top I have cos x sine x minus cos x sine x. And then on the top still, I have 2 cos x's. So those are similar terms. So a cos x plus a cos x is a 2 cos x. And this is where I get to. And now you reevaluate your life and see what you have to do next. So what you have to do next, you know, looking over here, that you want a cos on the bottom. You don't have that. So whatever you plug in here has to have a cos on the bottom. But I know that I have a cos up top also that I'm going to want to get rid of. So I'm going to want to cancel him out and cross him off. So I have to make sure I have a cos squared on the bottom. So when I cancel the coses, I still have 1 left over on the bottom. 1 minus sine squared x. Any takers? No? It's cos squared x. Okay. Are we good? So 2 cos x over cos squared x equals 2 over cos x. Now, like I said, we can cancel the coses, and there's only 1 left on the bottom. So up top, I have a 2, and on the bottom, I just have a cos x, which is what I want. We're happy. We're done. Good? How's that drink there, Cameron? Oh, good. Okay, 2 more. And we're going to start factoring now. Is that sugar-free Monster? Yeah. Because it's better for you? Monster, you might as well have to. No, it's fine with me. Oh, I don't know. I don't drink it. Okay. Avery's going to be watching this video and be like, oh yeah, there's Miss Wolf going on her random tangent. Okay, here we are. Cos 4x minus sine 4x equals cos 2x. Do we deal with 4, Sophia? No, we only deal with 2s or squares, right? So what can I do to that left side to make it squared only? And eventually I see on the right side, I'm going to have to deal with him. He's a cos 2x. He's one of these guys, right? But I'm going to leave that be for as long as possible and see what this complicated side whittles down to, because that might give me a hint on what I should do over here, which cos one I should pick. Okay, what do I do to make those 4's 2's? Factor out. Oh, yeah. Patience. Yeah, that's the difference. It's cos squared x plus sine squared x. Yeah. Yes, we do not factor out a 2. You cannot factor out an exponent. Never have been able to, never will be able to, okay? Okay, so that is a difference of squares. So we're going to have two brackets. Difference of squares, we minus a set, we plus a set, right? And just take the square root of each guy. The square root of something to the power of 4 is 2 because you chop it in half, okay? So cos 4x is cos squared x. That goes out front of each guy. Square root of sine is just sine squared. And on my right-hand side, I'll keep him as cos 2x. Let's just see what happens with my left side first, okay? Now, anyone see, look at the first bracket, the second bracket, but just start on the left again and just see a possibility. You know, is this maybe, I don't know, is this maybe like an identity already? Maybe? Oh, really? You don't say. Oh, is it that one? Yeah. Amazing. So cos squared x minus sine squared x has its own identity. And that looks really like my right side. So I'm happy because it means I'm getting close. Okay? So this whole guy subs out for cos 2x. Well, I want my right side to equal cos 2x too. So I kind of feel like I'm really close to being done. Anyone know what I can do with the second bracket and just call it a day? We're done factoring. It's 1. Cos squared x plus sine squared x equals 1. So that second bracket is a 1, right? So really at the end of the day, timesing by 1 don't matter. And we got cos 2x equals cos 2x. And we didn't even have to change the right side. So that's why you leave the simpler side alone, because sometimes magic can happen and you don't even need to touch it. Okay? All right. Fifth and final example. When I typed out your notes, I forgot to type the right side of the equation for you. So please write that in. That's my left side. I want your right side to look like this, cos x plus 2 all over 3 cos x plus 1. So there's your question. Clearly, my left side is more complicated, so I'm going to deal with that. Now, if you look up top there, you have a trinomial. You have a trinomial in standard form, ax squared plus bx plus c. And we know how to factor trinomials. Also, in the denominator, you have a difference of squares. So we're going to go and we're going to factor both the top and the bottom. We're going to cross off any brackets if we can. Then we'll reassess if we need to sub anything in or out. Okay? So if you so choose, you can do this factoring step on the side, and you can even choose to kind of ignore the coses and just go 3x squared plus 5x minus 2 and just factor that like you've been doing for years. Now, there's a 3 in front, so that's going to have to be a guess and check, right? We can't factor out that 3. But the good news is there's only one possible way to multiply for 3. It's 3 times 1. So that's my only option. And then the back number, I have to multiply for 2. So you can either go, don't write this down. You can go 2 or 1, or you can go 1 or 2. Now, if you're kind of in the process of guessing, the 1 goes where, the 2 goes where, look here. This gives you hints. Okay? We have a 3 cos x plus 1 deal going on. Don't we want our left side to kind of look like that? So that's how you know the 1 probably goes with the 3, because that's how it is right here. And we eventually want them to match. So that can just those can kind of give you clues of what's going to go where. So it's 3x and 1. You want your symbols right, though. So for it to add to a positive 5, you need to be negative 1x in the middle, and then a positive 6x on the outsides to give you a positive 5x. Okay. Then I'm also going to factor the bottom, but I'll do that right in the question because that's easy enough. So when I go rewrite my left-hand side, this whole trinomial up top, we decided it factored out to 3 cos x minus 1. So I'm bringing the coses back in now. Yes? second bracket was just cos x plus 2, I said. Now, on the bottom, that's a difference of squares, easy enough. Square root of 9, 3. So you have 3 cos x. That's going to be at the front of each bracket. And then your square root of 1 is 1. That's at the back of each bracket. You minus a set, you plus a set. And that equals your right side that we have not touched yet. Not much we can do there anyway. And believe it or not, all I got to do is cross off those 2 common terms and I'm done. Top of the left is now the top of the right. The bottom of the left is now the bottom of the right. So have I convinced you to leave the easy side alone for the most part, right? Do the complicated side. And that's that. Now, in your assignment today, read the instructions because the instructions in the textbook give you hints on how to start. So the instructions will say, use factoring to blah, 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 blah. So that's how you know you should factor first. There's some that say find common denominators first. That's what you know, how you know what to do first. And just for the record, for your test on Wednesday, I will do that as well. On your test, I will say start with factoring or use factoring 2 or first find common, just to kind of get you started. Make sense? Okay. Also, for your test on Wednesday, I'm not here. Okay, so it'll be a sub. But like I said, I'm going to make sure that the test has hints in it so that you're not just totally suffering when I'm not here. How do I stop? There we go. Leave.